Editor Prof. Editing, writing, plagiarism. Acceptable projects. Research proposals, papers, projects and thesis. Business writing and grant proposals. Books and magazines. Cover letters and resumes. Social media and blog posts. Range of services. Proofreading, intermediate, and deep expert editing. Plagiarism reduction. Writing. Contact details. Calls/WhatsApp +90 533 847 7359. Hire Editor Prof. We make your work look perfect.
Hello guys, I want to welcome you back to the AK Academics channel. Today we will continue our discussion on force and motion. We have done force and motion 1, force and motion 2, and now we would have force and motion 3. Let's get started. And don't forget, if you have not subscribed to this channel, do subscribe so that anytime I put in new content, you can easily get notifications and you can have access to those contents as fast as possible. Alright. Force and motion, general physics. A block whose mass, capital M, is 33 kg is pushed across a frictionless surface by a stick whose mass, small m, is 3.2 kg. The block is moved from rest, a distance d equals 77 centimeters in 1.7 seconds at a constant acceleration a. The first question says that identify the horizontal action-reaction force pairs in this problem. As you can see here stated in the question, we do have the hand trying to push a stick, okay, and the stick has a small mass as given here, 3.2 kg, and then the main mass that the stick is pushing through the hand is capital M, that is the main mass given here, and then we have our acceleration moving in the forward direction because the push is coming from behind. All right, and it is resting, the mass is resting on a frictionless surface as we do have here. How do we identify the action-reaction force pairs in this problem? Let's go ahead right now to do that. First of all, as we can see, when the hand pushes the stick, it pushes it with a force, and that force will be referred to as FSH. FSH means the force exerted by the hand on the stick. Or if you want to state it in another way, you could say the force exerted on the stick by the hand. This is the stick here, this is the hand. The hand is exerting a force on the stick. So the direction of that force will be forward because the hand is pushing the stick and exerting that force on the stick. So H represents hand, S represents stick, and of course our F represents our force. This is the first force that we do have here. But then, like we said, Newton's laws tells us that to every action there is an equal and opposite reaction. What is the force pair? What is the pair for this particular force? Let's find out. Okay, so as the hand is pushing the stick, we know that the stick would also be exerting a force on the hand, and that force would be the force of the stick on the hand, and that would be in the opposite direction to the force of the hand on the stick. The force the hand is exerting on the stick is FSH, and then the force the stick is exerting back on the hand as the hand is pushing is FHS, and it will definitely be in the opposite direction. This appears to be a force pair, so we can go ahead and say that our first pair of the forces we are looking for would be FHS equals minus FSH, and this supports Newton's law of motion that says to every action there is an equal and opposite reaction. Okay, now that we have the hand pushing the stick, we also know that the motion doesn't stop there. The stick is also attached to a mass, and then the stick is pushing a mass as the hand is pushing the stick. So we want to identify what is happening between the stick and the mass, just as we have been able to identify what is happening between the hand and the stick. Let's find out what is going on here. As the stick is pushing the mass, there will be a force exerted on the mass or on this body by the stick. We have the force of the stick on the body, or you can easily say that the force exerted on the body by the stick. Those are two ways you can actually represent that force. That is the forward force, the first force we want to identify here. That force is going to have a pair. What is the pair of that force? Let's find that right away. Okay, as the stick is exerting a force on the body would react and then exert a force back on the stick, and that force would be in the opposite direction of FBS. That force is the force of the body exerted on the stick, or the force exerted on the stick by the body. Now that we have identified these two forces, you can go ahead and say our second pair of forces will be FSB equals minus FBS. These are the two action-reaction force pairs in this particular problem. All right, this is very important. If you have any questions or if you have any doubt about this explanation, ask me in the comment section. I'm going to try to re-explain or respond to whatever questions you present in the comment section. All right, there is a second question attached to this particular question. The B part says, what force must the hand apply to the stick? We do know that we already have our force pairs here, and then we have this representation here. So let's go ahead and find it. As soon as the hand is pushing the stick, we do know that there are two masses in motion here. So we have the mass of the body, and then we have the mass of the stick. And we know that our force is equal to mass times acceleration. In this case, we will sum up the two masses because the hand is pushing the stick and the stick is pushing the body. So there are two masses in motion here. So that would be m plus m multiplied by the acceleration with which the stick is moving. That is how to find our FSH, the force exerted by the hand on the stick. Okay, so if we go ahead from the question given to us, we have mass capital M, we have mass small m, but we do not have acceleration. First of all, we have to find the acceleration using one of the equations of motion that we know. Here is the equation. We have x minus x naught equals to v naught t plus half a t squared. This is supposed to be half. Okay, this is half 1 over 2. X minus x naught equals to v naught t plus half a t squared. We do know right from the onset that our initial velocity, which is v naught, would be 0. So 0 multiplied by t would be 0. So we can easily cross v naught t out of the equation. If we do that, we are left with x minus x naught equals to half a t squared. Also, we do know that x minus x naught is the displacement or the distance traveled from one point to another as the motion is going on. Our initial distance is x naught, final distance is d. If you subtract initial from final, you have the change in distance. So that is represented by d. If we do that, what we would have right now would be rearranging this expression. So if you rearrange it, we would have a equals to 2 multiplied by x minus x naught divided by t squared. How did we get this? We have said this is 0, so there is nothing here anymore. The first thing you want to do is multiply both sides by 2. If you do that, you have 2 into bracket x minus x naught. That's what we have at the top here. And then 2 multiplied by 1 over 2 at squared. This 2 will cancel the 2, and then you're left with just at squared. And since we are looking for a, you can divide both sides by t squared. If you do that, you will be left with just a here, because t squared here will cancel t squared here. So we are left with just a here, and then we have x minus x naught divided by t squared. We have initially multiplied this by 2 anyway, so we have 2x minus x naught divided by 2 squared. That is how we find our a. If we go ahead and plug in all the values that we do have, we know our x minus x naught is d, so we can easily put d here. Then we have 2d divided by t squared. If we go ahead and substitute all the values given to us in the equation. In the question, we were given the distance as 77 centimeters. So to convert 77 centimeters to our SI unit, we'll divide it by 100. So you have 77 centimeters is the same thing as 0.77 meters. For d, you write 0.77 meters multiplied by the 2 we have right behind d divided by 1.7 seconds, all brackets squared, because our t from the question given to us is 1.7 seconds. So if you carry out simple arithmetic using your calculators, or if you can do that without using calculators, you would obtain a, our acceleration, to be 0.533 meters per second squared. This is important. Now that we have our acceleration, we can go ahead and use the equation for the force. If we do that, as we know, FSH as it is written up here is equal to capital M, the big mass, plus the small mass multiplied by A, and that will certainly give us the big mass plus the small mass, which is 33 plus 3.2 multiplied by the A we obtained, and that will give us 19.3 newtons, which you can easily approximate to 19 newtons, or you can just leave it as 19.3 newtons, whatever is convenient for you. So we have our FSH as 19.3 newtons or 19 newtons. I want to believe you understand what we have just done. If you have any question regarding this, don't hesitate. Go ahead and ask me in the comment section. I'm going to try to provide as much explanations as I can provide in addition to what I have provided here. Let's go ahead. Now there is a C part of this question that says, with what force does the stick push back on the hand? Let's see what we can do. Applying the Newton's law on the block alone, what do we have? We have FBS is equal to MA, because we are looking for the force with which the stick pushes on the block. The hand is pushing, the stick is pushing the block. So the force that the stick exerts on the block will be FBS, as we have explained initially, and that gives us FBS equal to big M multiplied by A, because the mass of the block is big M. We have our A and then we have the mass of the block. All we need to do is just substitute those values, and you have the mass of the big block is 33. Our acceleration as calculated on the previous slide is 0.523. If you multiply that by the big mass, as you can see here, you would obtain FBS, which is 17.6 newtons, and you can easily approximate that to 18 newtons, or you can leave it as 17.6 newtons. Now the next question we do have says, what is the net force on the stick? We have the hand pushing the stick, we have the stick pushing the body, so there is a force acting on the stick from the hand, there is another force acting on the stick by the mass. So how do we find the net force on the stick? Let's find out. The net force on the stick will be given as FSH, which is a force acting on the stick by the hand, minus FSB, which is a force acting on the stick by the mass. This is very, very important. Okay, you know FSB is negative because it is in opposite direction to FBS. So this is minus FSB here. So you have FSH minus FSB, and that gives us 19.3 minus 17.6 newtons that we calculated initially in B and C, and that gives us 1.7 newtons. So the net force on the stick is 1.7 newtons. I want to believe there is a solid understanding of this example. If you have any questions or any doubts in your mind regarding all the concepts and explanations discussed here, head towards the comment section and then ask me that question. And if there is any other way you think this problem can be solved in an easier and a simpler manner that you know, please don't hesitate to share such in the comment section so we can all learn from you.